Hey guys, Mr. Betts here. Let's take a look at an example where we're finding the area between two functions. A lot of times we'll be given a problem like this along with the graph, but I'm going to go through this problem and solve it without the graph. And then if we are given the graph, then that would just be an added bonus for us. So first thing I want to do is figure out kind of an idea of what this region is going to look like. We can see here that the graphs of f of x and g of x are going to be parabolas. One of them opens up and one of them opens down. One of the important things, though, that we're going to be looking for is hopefully the parabolas intersect, and so we're looking for where they intersect. And to do that, what we're going to do is we're going to set them equal to each other. So we're going to say 3x squared plus 2x, which is f of x, is equal to negative x squared minus 2x. And we're going to solve that for x. So we get everything on one side. We get 4x squared plus 4x equals 0. Factor out the GCF for x, and we get x plus 1. And so we have intersections here at x equals 0 and x equals negative 1. So regardless of what the functions look like, the bounded region is going to have to be between these 2 points, between x equals negative 1 and x equals 0. The next thing we're going to have to figure out is which function is on top and which function's on the bottom. So in order to figure that out, what I'm going to do is plug in a point between negative 1 and 0. So along the x-axis, we're looking at this interval, negative 1 to 0. So I'm going to plug in a point here. I'm going to plug in negative 1/2 and see which one is going to give us the greater value. So f of negative 1/2 is going to be 3 times negative 1/2 squared plus 2 times negative 1/2. Negative 1/2 squared is going to be negative 1/8. So we get negative 3/8 and then minus 1, which is going to give us negative 11/8. And then g of negative 1/2 is going to be the opposite of negative 1/2 squared minus 2 times negative 1/2. So that first term is going to give us a positive 1/4, and then the opposite of that is negative 1/4. And then we're going to be at plus 1, which is going to be positive 3/4. So that tells us that at this point, at negative 1/2 along the interval, g is going to be above f. So that's useful because we always want to do top minus bottom to find area. So now we can set up our integral here to find the area. So the area is going to be the integral from our left intersection, negative 1, to our right intersection, 0, of the top function. So remember, g is on top because 3/4 is greater than negative 11/8. So top function is negative x squared minus 2x minus the bottom function, 3x squared plus 2x with respect to x. Now, I want to point out at this point of doing the problem that knowing that these two intersect and knowing that one of them is a parabola that opens up and one is a parabola that opens down, we also know that the one that opens up and the one that opens down are going to intersect something like this. And so the one that opens down is going to have to be the top one, and the one that opens up is going to have to be the bottom one along that interval. So knowing what the functions look like, a basic idea at least, can help us determine the upper and lower functions. Now that we have this set up, before I take the antiderivative, I want to do a little simplifying. So this is going to equal the integral from negative 1 to 0 of, it's going to be negative 4x squared, and then negative 2x minus 2x is minus 4x with respect to x. To evaluate that, we're going to take the antiderivative. So it's going to be negative 4/3 x cubed minus 2x squared using the reverse power rule and evaluating that from negative 1 to 0. Plugging in 0, we're going to get 0 minus, plugging in negative 1, get negative 4/3 times negative 1 cubed minus 2 times negative 1 squared. So we get, this is going to be, this term here is going to be negative 4/3. Sorry, that's going to be positive 4/3. And we've got the negative out front here. So the opposite of 4/3 minus 2. 4/3 minus 2 is negative 2/3, and the opposite of that is positive 2/3. So the area that we get here is positive 2/3. Now, like I said earlier, a lot of times we're going to be given a problem like this and be given the graph. The graph will give us not only clues as to which one is on top and which one is on the bottom, but also ideas about the intersections. We never want to assume that an intersection is exactly where it looks like on the graph. So even though it looks like -1 and 0, we would want to confirm that algebraically in some way. And then it also tells us that the parabola that opens down is the top function, so that's going to have to be the g of x. So this does give us some clues, but we're still going to have to use algebra to evaluate that integral.